Okay, I need equations because I don't have a paper. I thought I posted them with the assignment. Sketch these on a graph real quick. So square root of x looks like this. X over 3 looks like this. But this one said perpendicular to the y-axis, so I need to be with respect to y instead of with respect to x. So I'm just going to rewrite these a bit. This is going to be y squared equals x. This is going to be 3y equals x. Okay there. And here is my cross section. I'm a rectangle, and I'm a rectangle whose height is 6, which means the only thing I'm lacking is my width. Oh my gracious, I can't even write. Width. My width is going to be the length of this cross section. So since it's with respect to y, this is right minus left, right? So 3y minus y squared. Everybody okay with that? So the area of the rectangle is going to be 6 times 3y minus y squared. That's the width, right? That's this cross section. I'm going to order that little cross-section thing. I'm going to look on Amazon. Y'all remind me whenever I'm done teaching. And I'm going to order that. Not, I mean, it won't do y'all much good before I'm done. I'm going to have it. All right, so now I need to integrate. And I'm going to integrate from 0 to what is the y value here where these intersect? 3? I thought it was 9. Oh, it's 9, 3. Okay. Sorry.
3.
Good, Robert. And now I'm going to do 6, 3y minus y squared. y. Could have used the calculator, didn't have to. It's pretty easy. Antiderivative. 3 over 2 y squared minus 1/3 y cubed from 0 to 3. 3 squared is 9. 9 times 3 is 27 over 2. What? 9. It's 18 over 2. 6 times 9 over 2. I got 27. So what y'all got? I like these.
Good.
Is that what you did the X way? You really, 90% of the time, you're with respect to X. All right, what else did you say? X-axis 1, let's see, rectangle. All right, let me draw. Yeah. Square root 1 minus x squared. This is y equals, what am I perpendicular to? I'm going against the x-axis. And it's a rectangle whose height is, what did it say, 10 times the width? 10 times width. So I need to know what is width so I can find out what height is. So what's the width? Am I squares? I mean, no, rectangles. I already said that. Get it together, Shaky. What's the width here? What is the length of this? That's right. It's just the equation itself. Square root of 1 minus x squared. I'm sorry. I didn't even hear. I thought I heard something. I looked and I didn't see you. That's okay. Don't. So my height is 10 times that. So I'm just going to plug in. So it's going to be 10 square root of 1 minus x squared. Okay. So the area then, and here, if you use the calculator, I think this is one that we looked at yesterday, that if you use the calculator on, it started giving you like imaginary number type thing, and it wouldn't calculate the integral. Because here, our area is 10 square root 1 minus x squared times square root 1 minus x squared, right? Which actually is just 10 times 1 minus x squared, because those radicals can cancel each other out, because I'm just squaring them there. Does that make sense? So now I'm going to integrate, but I'm integrating from -1, yes, or 0 to 1 doubled, either one you want to do. I'm going to put that 10 on the outside, 1 minus x squared dx, because this is a pretty easy integrate by hand. X minus a third x cubed. But again, some of you like to do this, and that's okay. Same thing. Um, 1 minus oh, thank you, golly. Sitting here thinking that was 0. This is 0 over here. 2/3, 10 times 2/3 doubled would give me 20 over 3, 40 over 3. For 1. Am I going the right way? This? Okay, so we're going, let's see, cubed root of x, y equals 2. And what did it say? Respect. Oh, this is the one I gave you the problems. I said respect to x, semicircles. Is that right? So my cross section is what in relationship to my semicircle? It's the bottom, which is the what of the circle? The base or the diameter. There you go. So this is going to be the diameter. So the diameter of my circle, which is not what I need for area, but the diameter of my circle is going to be 2 minus cubed root of x, right? Yeah, you've got a circle coming out so you can whoop, poke it right after. Yes. If I had a circle, if this is your graph, sitting on there just like that. Like it's sitting. Okay. So this is the diameter, right? So the diameter is 2 minus cubed root of x. Which means, but I need the radius for the area, yes? So radius is half of diameter. So the radius is going to be half of 2 minus cubed root of x. Okay. You can leave it like that. You could write it as 1 minus cubed root of x over 2. It doesn't matter so long as you have that radius there, okay? Now the area, because remember, to find volume, I'm integrating area, right? So I need the area of 1 so that I can integrate for the whole thing. So the area of 1 semicircle, half, right, of the area of a circle. How do you find the area of a circle? Pi r squared. Pi, well, r 1 minus cubed root of x over 2 squared. Pi r squared. You said the answer? I don't know what the answer is. Hold on, I'll plug it out. We'll have to plug this one in the calculator. This one's kind of, yeah. I don't even really have to, but it's better. It's better that way. What am I integrating from? From what to what? 0 to 9? 8? I'm going to put that 1/2 on the outside. Actually, I'm going to put the pi, I'm going to put 1/2 times pi on the outside. Pi over 2 on the outside. Inside, I'm going to do 1 minus cube root of x over 2 squared, and I probably am going to go ahead and use my calculator to find this. I'm not going to try to do that now. 1 minus cube root of x over 2 from 0 to 8. 1 comma. I got, well, I was thinking about it right now. Okay, but remember, you still got to multiply it by pi over 2. $1.256. Yeah. That's not what you got, Stella? I bet it is a print. Make sure you're squaring this whole thing and not just that fraction on the end. That's what I did the first time. We did that semicircle one, number 1 and 2. We didn't do the one you said we don't need for. All right, then the triangle one. I think the triangle one was probably the hardest one. So I've got square root of x minus 1, 2 and 3. X equals 3. All right, so here's my region. And here's my cross section. Now this cross section is the base of an equilateral triangle. All right, so this is where it gets sticky. There's my base, equilateral triangle. I can easily find my base, right? That's in my equation. What's the length of the base? Square root x minus 1. And that means I know all of these are the same because it's equilateral. The problem is I have to drop down to find the area of a triangle. I have to have the height of the triangle. I've got the base, but I don't have the height. So I've got to drop down, and I'm going to drop down at 9 degrees. Now, because it's equilateral, that height is dropping down and splitting into 2. So really this is square root of x minus 1 over 2, square root of x minus 1 over 2. If you like Pythagorean theorem, I think that's what y'all did yesterday with Pythagorean theorem to find that missing side. It sucks to do that. I would think so. This way, I would use special right triangles on this because it's a really easy solve if you know your special right triangles. This is what you should have learned in geometry. 30, 60. This is the short leg. Short leg's always across from the smallest angle because as the angle gets bigger, the side the connecting ends gets longer, right? So the smallest side is across from the smallest angle. So my short leg, I always get myself back there because everything is based off the short leg. The hypotenuse is twice the short leg. Well, that makes sense. Look what I have. Or divided by 2 to get backwards, right? That holds true in my triangle right now as it is. Now to get from here to here, you multiply by the square root of 3. So you